Alright, okay, let's look at this question carefully. I'm going to use this question to explain about what is the meaning of mutually exclusive. Right? A box contains 10 balls, label 10 balls, which label with the numbers 11 to 20. Or we can just assume this to be a number, right? Means that inside the box, so we have 11, okay, 12, 13, 14, 15, 16, 17, 18, 19, and 20, right? So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So total they are actually 10 balls, right? Then we're going to list out the events here. This is the universal set because a box, right? So this is a universal set. So where is contained, right? It's contain all the balls, right? With label with 11 up to 20. So an A is an event of getting a number smaller than 18. Right? A number smaller than 18. So I'm going to list out here, easy for me. So A is the event, so smaller than 18. So it's 11, 12, 13, 14, 15, 16, 17, right? Up to 17. Because why? All this number is smaller than 18, right? Let's look at event B, right? Event B. So this out, so event B, so it's an event of getting an prime number, right? And prime number. So prime number, which is the prime number? Prime number is a number that can divide by itself and factor 1, right? And 1, right? So it's 11, right? Only have two factor, 11 itself and 1. So 11, 13, 15 is not a prime number because 15 can be divided by 3 and 5, right? No, it's an odd number, but it's not prime number. So the following will be 17 and 19, right? 17 and 19. This 4 will be the prime number, right? Out of the 10 numbers here. So, and C. C is an event of getting an even number. So even number is a number that divisible by 2. So 12, 14. 12, 14, 16, 18, and 20, right? This 5 number is an even number, right? Because it can be divided by 2. So a very easy way to identify this will be using this question to identify whether the events the first question will be determine whether the following two events are mutually exclusive or non-mutually exclusive. So very easy. You look at event A. Now the first one is event A and B. Is these two mutually exclusive? No, they are not mutually exclusive because they have a common, right? Can you see that? They have an intersection between these two, right? 11 and 13, right? 11, 13, and 17, right? So they are not mutually exclusive here, all right? So I'm going to draw the diagram for you, the Venn diagram. All right, okay, it's easy for me to explain by using Venn diagram to explain about mutually exclusive, right? So if you look at event A, okay, now we talk about event A and B, right? Event A and B. So event A and B, right? A and B, right? And B. So we have 11, right? For event A, we have 11. Okay, these are event A and B. So if you look at these two events, right? They are actually sharing the same element, right? 11, 11, 13, 13, and 17, right? So means that here we have 11, the element, right? 13 and 17, right? Means there is an intersection between A and B. So from here we can say that these two events are not mutually exclusive. Events A and B, events A and B are not mutually exclusive, right? They are not mutually exclusive. So because why? They are non-mutually exclusive event. Okay, events A and B are not non-mutually exclusive event because why? There is a intersection between A and B, right? So between A and B. So means that this is not mutually exclusive. All right, let's look about event B and C, right? All right, okay, let's look at events B and C, right? Event B and C, right? Is these two mutually exclusive? Very simple, you also can see from here. Is there any element that they are sharing the same element? Right? No. 11, there's no 11 here. 13, there's no 13 here. 17, no. 19 is not here. These two, they are not intersecting, right? They are not intersecting. So if I'm going to draw it into the Venn diagram, I can show that C can be, but C and A, they are sharing the same element, right? Which is 12, right? Which is 12 and 14 and 16, right? 12, 14 and 16. So I can redraw this Venn diagram. So there is a sharing between A and C, right? A and C. So which is 12, right? 12. These two, A and C. 12, 14, and 16, right? 12, 14, and also 16, right? But B and C, right? Event B and C do not intersect, right? B and C, you see, the event B and the set C, right? The set B and the set C do not overlap, right? Do not overlap. This is called overlap, right? They intersect, right? A and B. So A and B are not mutually exclusive. And A and C also, right? Event A and C, right? A and C also are not mutually exclusive. They are not mutually exclusive. But event B and C are mutually exclusive. Very simple, right? Event B and C are mutually exclusive. Or the other way of explaining this will be, you can see that the number of elements of A and B, right? A intersect B. You are getting how many elements here, right? You are getting how many elements? You have 3 elements, right? You have 3 elements. Or we say that A intersect B, we have a common element, right? Which is 11, 13, and 17. 11, 13, and 17. So therefore, this event A and B are not mutually exclusive. And A and C also, the number of A and C, right? A intersect C, sorry, A intersect C, you have 3 elements also, which is 3 element. Number of element, we have 3. And what is the element that they are sharing, right? So is 12, 14, 16, right? 12, 14, and 16. So they are also non-mutually exclusive. But you look at the set B and set C, right? Set B and set C. So event B and C. So there is no element sharing between B and C, right? They never overlap, right? B and C. Or we say that the B intersect C is actually an empty set, right? Empty set, or this way, right, of writing, empty set. So as long as the intersection between the 2 events, okay, I repeat again, as long as the intersection between the 2 events is giving you a empty set, right? So we said that the 2 events are mutually exclusive. So now for this case, B and C are mutually exclusive, but A and C are not mutually exclusive. That's the meaning of mutually exclusive. Hope you understand.